Next one is compensation. So if you don't achieve the required gain margin and phase margin, how are we going to compensate for that? So we have developed a number of methods for studying the stability. For example, root locus will clearly say how the path is going to change from the poles to the zeros. By constructing root locus, we can easily find the transmission poles and zeros. So definitely gain margin and phase margin will clearly give the knowledge of what is the how the gain and phase are varying with respect to frequency. So one way of achieving compensation is through gain reduction. So we are going to shift our focus away from analyzing stability to changing it. So various compensation techniques are available. Among the stability, desensitivity, many methods are available. Now we are going to consider phase margin as a stability measure. We assume that if the for an uncompensated system has a negative phase shift as the frequency increases, then the stability can be improved by simply reducing the crossover frequency so that the phase margin is less negative. The phase margin being negative will affect the stability of system. So if I am by some technique, if I can control that, if I can make the phase margin to be less negative, then I can control the stability of my system. Okay, so one very crude way of achieving less negative phase margins by your reduction in the crossover frequency. So since using an attenuator, I'm going to reduce the gain. So I have to attenuate. I'll be going for attenuator. So attenuator will just reduce the gain. It will not affect the phase of a phase angle of your system. So just an op amp you can take, and in op amp you can design attenuator network, which will just reduce the gain value so that the phase margin is going to be relatively less negative. So if you can take this transfer function, and if we connect op amp in an inverting fashion such that the R1 by R2 value is 99, then you can have this formula for transmission. So the gain value is reduced by 1000. It is reduced by 100. So the gain value is reduced. Now, if you compute the phase margin for the final system, you can find that it will be less negative. Okay, so that is one way of reducing the one way of compensating is by reducing the phase margin or making the phase angle less negative. And the crossover frequency is going to be approximately 10 power 4 radians per second. The computation of phase margin is also going to be not easy. It is going to be trivial when you have a lot of crossover between the poles. Okay, so that is also going to be a difficult task. With such small phase margin, we expect overshoot in response. Okay, so if you find that the phase margin is going to be reduced, and slowly it is going to become zero, then the other time domain and frequency domain parameters are going to change. So in short, stability is very unsatisfactory. So whatever method we have applied, the gain reduction with that, if we find stability, the stability is going to be